Viator again from Rhode. What I'm going to show you here is some data from the TMDL we're getting ready to release for public review, probably within the next month. My boss approved it. It's talking about the Blackstone water quality restoration. And I apologize if some of the slides are busy. I have a couple of busy ones, but most of them are pretty readable. I thought it was going to be nice and big. Next slide, please. Basically, overview, I'll talk about the Clean Water Act. Really, I don't know if everybody knows about it. Back in the 70s, impairments, water quality data, pollution sources, and required pollutant loading reductions. The TMDL we're working on is actually for metals and bacteria. It's not nutrients, and it doesn't include the whole watershed, but it does include most of it in the Rhode Island portion. Next, please. Okay, Clean Water Act. The biggest thing is establish water quality standards. Monitor and assess and report. Identify, list impaired waters. We do that every 2 years. It comes out with a list of impaired waters, our 303D list. We just had one released for 2012. It was approved by EPA. And then prioritize a schedule for developing total maximum daily loads. That's what the TMDL stands for. And when I first heard of a TMDL, I had no clue. So, next slide, please. So it's nice to know what they are. What is a TMDL? The Federal Clean Water Act requires to monitor the quality of the water and identify those that don't meet water quality standards. We have to look at the impaired waters that are put on the 303D list and decide which ones will be chosen. We have a priority listing of which ones we can, we have, I think, 2020. And these are called TMDLs. And they identify the corrective actions. They identify, hopefully, where the pollution sources are coming from and the requirements to clean up the sources. Next step. Okay, these are some of the impairments in the Blackstone and the Rhode Island portion of the river. And this, this includes all the tributaries. And you can see you've got the branch, the Blackstone, Cherry Brook, Mill River, Peters River, Abbott Run Brook, which is in the northeast side of the Blackstone, and two ponds. And these are all their water quality impairments. They all have a class of water quality class. This is drinking water quality. Abbott Run is actually a water quality, is a water source for Woonsocket. And anyway, the TMDL is going to be on both segments of the Blackstone River. And it's going to talk pathogens, cadmium and lead. The lower portion, cadmium and lead. Cherry Brook, which is a pretty good sized watershed in the northwest side of Rhode Island. Pathogens and copper impairments. The Mill River is pathogens, and the Peters River, for the two tribs in Rhode Island, pathogens and copper. Next.
What's the difference between Class B and Class B1?
B1 is just whether it's for contact or non-contact. So make sure I'm right in looking at what it is. Yeah, but that's what it is, non-contact or contact or just recreational. And so they, you know, it depends on the use, like water quality. If you're going to use it for drinking water, you really have to have a pretty good clean water source.
So boating versus swimming standards?
Yes. And aquatic. Oh,
so it's subject to impact from non-voiding.
It's subject to influence from wastewater treatment facilities.
Yeah, I'm sorry, I forgot that part. Rhode Island, this is the Rhode Island segment. This is the Branch River, which was, we had a station when we did the study collecting data over here on the branch right before the confluence with the Blackstone, but that's going to be a separate TMDL. So this is the portion of the river watershed that we're talking about. But if you look at it, it's 48 miles long from total and 454 square miles, about 25% of that is in Rhode Island. Next, please. Some of the water quality modeling or monitoring that's been done includes Narragansett Bay Commission. They run every year, they give us a report. They're on the CSOs in the lower portion of Blackstone. They have quite a few. And then you have two main stem stations at Whipple Bridge, which is and Slater Mill Dam. USGS has 3 stations on the Blackstone main stem. One is at Millville in Massachusetts, right across the border. and Manville Dam, which is in Manville and Roosevelt Avenue in Pawtucket. The University of Rhode Island Watershed Watch, they provide a lot of data on a lot of different water bodies. They have a site that they visit at Manville Dam. Rhode, we have a rotating baseline monitoring program, which every 5 years it changes. So on a rotating basis goes to different watersheds. And it looked at Cherry Brook for the Blackstone. And then we had the Blackstone TMDL study, which was a 1 year, about a 14-month program where they went out and took dry weather samples and wet weather samples and did a lot of surveying. One of the consultants, Louis Berger, and we used that for the TMDL. That was our data source, most of it. Next slide, please. Okay, this is a flow duration curve. The reason I put this on, it basically shows the characteristics in one picture of all the discharges in the river for the period of record. In this case, it's 1929 to 2009. What's important is like right here, 90% of the time you have at least 168 CFS or cubic feet per second flowing in the river. And all these dots indicate what type of, whether it's a USGS survey or whether it was one of the Blackstone TMDL water quality surveys. And so you can see that the data we used to develop the TMDL is covered just about the whole range of flows in the Blackstone. We had some pretty high flows as well as some pretty low flows. Next slide, please. Okay, this is it. I put this out in two areas, but basically showing you all the stations in the upper portion. This is Manville Dam, as it is here. You got Cherry Brook, is this watershed. You have the Mill River coming in and comes out of Mass, as well as the Peters River on this side. And then here is Abbott Run Brook coming down. And this is the main stem, which follows all the way down. This is Pawtucket. We had 18 stations total that we looked at. 11 of them were on the main stem, 7 of them were in tributaries. And these are the communities basically in the northern and the southern portion of the watershed that border on the Blackstone main stem. Next slide, please. This is a busy slide, but what I want you to take away from this, if you look at it, here are all our stations that we had. This is the water quality fecal cold form data. And all samples, all reaches, all stations were violated or exceeded the sampling limit, the water quality limit for fresh water. In all reaches except where Mill River comes across the state line. That was the only station that didn't exceed our water quality standard. So there's a lot of problems, and this is both water quality standards were exceeded. You can see the number of samples varied by station, but we had a minimum probably about 45 to 49, 48, 47 samples taken. USGS is also included. This is Roosevelt Street station right there. So we have when we looked at intercoxy, which was the other pathogen that we looked at, you had a similar type results. You had exceedances in all reaches on pathogens, whether it was fecal or intercoxy. The difference is shellfish versus aquatic. Next slide, please. And the requirements the TMDL is going to come out with is the reductions required for each station, each segment. Right here, coming across the border, we're going to ask for a 93% reduction in the bacteria. This includes a 10% margin of safety. Margin of safety just ensures that you have a little breathing room for the uncertainty of the sampling. You know, you might have a high sample or a low sample, or you might not. It might not be consistent sometimes. It depends how many samples you get. So the bigger the sample size, the better you get. And but each, you can see this, it is the highest reduction required, and we apply that to that segment. This is the upper Blackstone segment. For the lower Blackstone, we're not requiring a pathogen TMDL because of the CSOs. They just spent all that money digging that big hole in the ground, and they're doing another big hole. And we're going to see how it works before we require everybody to jump through hoops to clean it up. And hopefully it looks like it is working. It's, when I first started working on Blackstone, I remember going up to Fields Point and sampling the bypass during a wet weather storm, and it was nasty because it's raw sewage being dumped into the river, and that's not something that anybody would like. So this is a really good, valuable program that the state's come up with. You can see Mill River in Rhode Island, we're looking at 97. They're all up in the high 90s. This is probably the lowest. If we can get a 90 to 95% reduction, we'd consider that a success. And this is a concentration-based reduction. Okay, next slide, please. Okay, for dissolved metals, we have the targets that we're looking at, actually, we're looking at cadmium, copper, lead. And they're hardness dependent. Hardness, the harder the water, the less toxic the metal is to aquatic life, and that's the biggest thing. We have a 1 hour average, which is acute, applies to the acute criteria, shouldn't be exceeded more than once every 3 years. However, if we have an exceedance that's really high enough, we can say, well, we think that's a problem, even though it's only one time. We may think that it's a problem, and we may decide to act on it. So the 3 year is something we look at as well. And then you have the chronic type criteria as the lowest criteria, and it's a 4-day average concentration. And it's required to be achieved in all waters and all mixing zones, regardless of the class type. Next slide, please. Okay, from that flow duration curve, we developed load duration curves. The load duration curve shows the load that's allowable in the river through all flow regimes. Applying the criteria, hardness, this took a few tricks, and if you look, there's the blue line here is a chronic criteria curve. That's the lower, more protective criteria. If we wanted to put the acute criteria on there, it'd just be a little bit higher. These red diamonds represent the data or the load for the different USGS surveys that we took, and this happened to be at Manville Dam. When we did the 1-year study with Louis Berger, we didn't find that there wasn't a lead violation, either wet or dry weather. However, when I looked at the USGS data, I did see violations in lead and cadmium. And it just so happened that the study we did didn't include cadmium, but the USGS data did. So these are all in violation. You can see the amount of, this is pretty good sized storm right here. You can't expect everybody to reduce their cadmium or lead load at this level because they might be at this low. So that's why we have a low duration curve. EPA really likes doing this. Next slide, please. The summary of the dissolved metals is basically we had violations of metals criteria only during wet weather events or high flow events. We looked at that flow duration curve. We picked a point at 60%. 60% and below in the percentage flow percentiles means it's starting getting the higher flows. So that's considered wet weather, high flows. So you can have, like, remember in 2005, we had almost a month of high flows. If you remember those pictures of downtown Pawtucket with flooding right there at the Horseshoe Dam. Cadmium violations were only on the Blackstone River, but that's only because we didn't have the cadmium data for the tributaries. So we're not really sure, but from what we have, the Blackstone has cadmium violations. Exception of a single wet weather event on the Peters River, all violations were for chronic criteria. The Peters River had one wet weather storm we collected data for that was acute violations. It's a higher level of pollutants. But this is all the rest were chronic. And there were no violations of copper on the Blackstone or the Mill River. The Peters River did have copper violations. The Blackstone has a site-specific criteria due to the fact that it has the water treatment plants that dump into the river all along its main stem. So in Rhode Island, you have Woonsocket water treatment plant. Next slide, please. Okay, the final range of requirements we're looking for trace metals, and this we have a range here because it depends on the flow in the river. And if you look at this right here at the Rhode Island state line, cadmium and cadmium lead, this represents what we're looking for in reduction, depends on the flow. And this is what the observed loads were, depending on the flow at the time. Yes?
What is the source of the cadmium in the river?
Well, you have, autos, batteries, you have cadmium plating. There's a lot of different, cadmium comes from a lot of various sources, but it's a toxic element in higher concentrations. So I can't say for sure, I can't point to where.
So I'm trying to figure out how we could reduce it in the river if we knew.
Well, when I mentioned wet weather sources, I know Director Stone here talked about wet weather and impervious surfaces. That is what we're pushing for. You have a lot of stormwater now. Everybody likes to point an easy solution saying this is the treatment facilities, it's an industry. A lot of industries are going to recycling their wastewater. A lot of industries are starting to put in BMPs so that this stuff is treated before it ever gets to the river. The two treatment facilities, I actually looked at the Woonsocket treatment facility for cadmium lead, and since I started working on the Blackstone back in the 90s, they have gone down by a factor of 10 as far as what they're putting out in cadmium lead. They're way below what, they're at the permit limits, actually below their permit limits.
Could it be legacy sediments from industrial?
Yes, you have a lot of impoundments, and I can't, it's hard to separate out resuspension type cadmium from what might be coming off the roadway runoff or parking lots and things like that. It is really tough to, we tried to in the Blackstone River Initiative study, try and separate it out, but it's tough. With Wright City Pond, you have up in Mass, when the dam failed in the 50s, they lowered that dam level, and I've been through that area many times. Over a year, I was there about every 2 weeks, and sampling, and there's a lot of sloughing going on, even in lower flows. So when you get some of the high flows, and believe it or not, the average flow in the Blackstone, I'd say during the springtime, is maybe you're looking at 2,000 cubic feet per second. That's pretty high. Looking at some of the high flows that you see, the potential, that's 29,000 CFS has been recorded in the Blackstone in Woonsocket. So I can't imagine that amount of water coming through some of these impoundments without scouring a lot of this stuff and transporting it downstream. Yes. Yep. So anyway, next slide, please. And these are some of the pollutant loads or sources. This is instead of looking at a lot of different slides with data on them. You have CSOs still a big problem for metals. Illegal sources, pet and animal and waterfowl are always a problem. And urban runoff is going to be the biggest thing we're looking at with the stormwater utilities and things like that in the future. That's it. Next slide if you want. This is Elizabeth Scott is my immediate supervisor at Rhode, and this is my contact information, or I have cards if anybody wants. Any questions for me now or later? Thank you very much.